Parent circle and transformations. So remember, parent is where you come from, right? So your parents created you. So we're going to have a circle that's going to create a bunch of other circles. And it's kind of what we did before. This is a review of the last unit. So the parent circle is a circle with center at 0, 0 and a radius of 1. It has the equations, okay? This is all review. X squared plus y squared equals 1. Or you can type it out the long way with the 0, 0 as the center, even though those actually cancel out in the formula. X minus 0, y minus 0, and 1. And they're all squared. When we change the h, k, and r values in the equation, the circle is transformed from the parent. Observe the transformations when you change the values using the sliders below. So here's our formula, h, k, and r. This should all be familiar. As we adjust our h, it's next to our x, so we go left and right. Left and right. And then the k next to the y, so it's going to change the y-axis value, up and down. And finally, our r is our radius. So as our r gets bigger, our radius gets bigger, thus changing our circle size. Okay, so all that was just a review. Question 2, which is the first real question. Select all the ways that the graph of the parent function is transformed when the values are changed. So here's our formula. The r value makes the circle smaller when the a is greater than 0 or less than 1. That is true. That's a decimal or a fraction. The r value stretches the circle bigger when a is greater than 1. That is also true. Stretches means making it bigger. Actually, it says that right here. H value, so that's next to the x. I always look at that, see which one's it's changing. So that h and x means it's horizontal. Shifts the graph horizontally, right if positive, left if negative. This one says vertical. We know that's not true because that's the k value. And the k value shifts the graph horizontally. That's not true. It's vertical. So the very last one's in the last correct option there. Question 3 is here you go. Parent quadratic. I thought something different. The parent quadratic function is y equals x squared. Okay, so this is the parent function of a quadratic. Remember the parent function of a circle was x squared plus y squared equals 1. This is the quadratic formula or form. Use the equation to fill in the table. Add as many points to the table as you would like. So we're just going to simply plug in -3 into our formula. So -3 squared is -3 times -3, which is equal to +9. Remember, two negatives multiplied equal a positive. -2 times -2 is 4. -1 times -1 is +1. 0 times 0 is still 0. And these are the same numbers we just discovered, 1, 4, and 9. And you can see our graph, it plots it automatically. We are plotting a quadratic, which looks like a V or a U, a bowl. If the number in front of the X, which we're going to see in a second, is negative, it's going to flip the graph upside down. Okay, next question. The parent quadratic function is y equals x squared. We've already seen that. The rise and run between the points 0, 0 and 0, 1 is shown on the graph. Draw the rise and run between all consecutive points next to each other. So we can see one set here from the vertex, which is down here, 0, 0, over 1, up 1. So we're going to draw a run of 1. And look how far we move up now. We only ran 1, but we rose 3 this time. This is labeled the height of each rise in the step. So if that one was 3, this is 1. Well, we run again, and we're running how high now? 1, 2, 3, 4, 5 up. So what do you notice with these numbers? 1, 3, 5. It's increasing. So as we go 1 out, we are increasing by going up more. So our slope is changing. -1, up 1. -1, up 3. -1, up 5. So 1, 3, and 5. And you can see that we're also symmetric. So what do you notice about this graph? So one thing I notice is as we continue to run 1 step away, we rise more and more each time. Okay, so that's one thing you can put in there if you want. Share that with class. I will pause for a second. All right, next question, question 5. All right, now we're going to be playing with some values in our equations. So use the slider for the a value. That's the number in front, all right? And this has tricked some students before to explore how changing the a value affects the graph. So if, in this parent function right here, there is an a value here, what number is it? It's 1. It is not 0, okay? So later in the assignment, make sure that you put in 1. If there's no number in front, it's 1. If there were 0, this would go away. 0 times anything is 0, which means nothing. So here's a graph we're going to be playing with, y equals ax squared. So our a is a multiplier or a coefficient out front. As our 1 increases, what's happening to our graph? It's stretching more and more and more. Look, remember earlier when we did the rise and run? So we run 1, actually I'm going to go to the positive. Run 1, and now we're going up way up to 5.3, which is this number here. So before it was just 1 over 1. Now we're going up to 5.3. So it's changing that factor out front. And then let's go down to less than 1. What happens? Oh, it flattens, or it gets fatter. And then 0, it's just basically a line at 0. It goes away. And then what happens when we go negative? Boom. It flips upside down. What I want you to notice is the vertex never changes its location. It's still at 0, 0. You see how it always stays at 0, 0? It's really important. Question 6, how does changing the a value change the graph of a quadratic from its parent function? Okay, well, as a increases above 1, our graph stretches vertically. As our a, decreases, this is important, below 1, but above 0, so it's a fraction / decimal, then our graph flattens out. And when our a goes negative, our graph reflects across the x, yeah, that's right, actually, axis. I also noticed our vertex never moves. Okay, I'm going to pause my screen. Question 7. Okay, now, so if you look at the, we're using a different slider for a different value. Our a value is no longer changing. Okay, so the number that was in front of our x squared is not going to be changed. We are changing a number at the very end of it. Okay, this could be called a constant if you remember back in your regular algebra days. Use a slider for k value to explore how changing the k value affects the graph. So right now k equals 0. Well, as k increases, what happens to our graph? It simply moves up. The vertex is just moving to whatever value is at our k. That's all that's happening. Back down to 0 and negative. Now when it's negative, it does not flip our graph. It just moves it down. That's all that's happening. Can I what? Oh, I'm froze. All right, so we know now that k just changes our value up and down, or sorry, vertex up and down. So question 8, how does changing the k value change the graph of a quadratic from its parent function? As k increases, our vertex moves up, and as our k decreases, our vertex moves down. I also noticed our graph does not change shape, nor does it reflect anywhere. Question 9. All right, so use a slider for the h value to explore how changing the h value affects the graph. So very similar, but now if you look at where our h value is, it's inside. And I want you to notice there's a negative sign, just like the circle. Okay, remember when we found our center for our circle, we had to change the sign? So it's going to be very similar here when we do the assignment next, is that whatever our h value is, make sure you change this sign. So when I move this h to the right, this is saying x minus, let's say, 4. Oops, there you go, 4. So x minus 4 moves our graph to the right. So it's a little bit backwards, kind of like the circle. and then we move our h to the negative side, what we're getting is an x minus -4, which means this is really an x plus 4 inside of here. So it's going opposite direction. Be very careful with that, all right? And one more thing to think about, I know it's asked in the assignment later, is what is our k value here? The k value here is 0, and our a value is what? It's not 0, it's 1, okay? So those are different. They're both not showing directly what they are, but there is a 1 here, and there is a plus 0 here that are invisible. See, if I delete both these things, our graph stays in the exact same spot. Question 10. How does changing h value change the graph of a quadratic from its parent function? As our h value increases, our graph moves to the, and as our h value decreases, our graph moves to the left. I should actually say our vertex. This is a little more specific. Question 11. All right, now we have all 3 sliders. All right, so this is just an exploration. Use the sliders to explore how all these values affect the graph when they are changed. So A, H, and K. So remember, A is the value out front. This should make it stretchy as we get bigger. As we get less than 1, it flattens. Until we get negative, it flips upside down. Our H value is the one that's next to the X. So it's going to be our horizontal change, right and left. And finally, our K is our constant outside, and this is just going to change our vertical location of our vertex. Question 12. Select all the ways that the graph of the parent function is transformed when the values are changed. So the a value reflects the graph across the x-axis when it is negative. That is true. It's the x-axis, not the y. Okay. The a value compresses the graph vertically when a is greater than 1 or a is greater than less than -1. Or the a value stretches the graph vertically when a is greater than 1 or a is less than -1. This is the correct one. Compresses will be flattens. Okay. H value shifts the graph horizontally. H is next to the X. That is correct. The H value does not shift it vertically. The K value does not shift it horizontally. The K value does shift the graph vertically. Okay, so that's the first one, the middle two, and the last one. Which equation describes a parabola that is reflected across the x-axis, shifted 2 to the left, and shifted up 3? Okay, so reflected across the x-axis, that's the first stat or important thing. Well, that means that we have to have a negative sign. These first two do not have a negative sign out front. So the first two you can cross off right away. So it's between C and D. Shifted 2 to the left and shifted up 3. Well, you can see they're both shifted up 3. That number is the same. So the only thing that's different is the number that's in, or the sign that's in here. Remember, shifted 2 to the left is going to the negative sign. So it's going to be x minus -2. X minus -2 is really x plus 2. Because we shift left 2 units, the inside the parentheses is x minus -2, which equals x plus 2. And I spelled parentheses wrong. Question 14. Which parabola is the graph of the following equation? We have a 3 out front, so they're all stretchy, and they're all the same. That's good. X minus 4 minus 2. So this is going 4 to the right and down 2. 4 to the right, down 2 is this guy right here. The other ones are all not the same, but they're all the same shape and all going up. So that's all correct, but the location of the vertex is not. Question 15. Describe all the transformations from the parent function for the following quadratic function. Here's the actual answer for this last question. I ran out of time on my video, so I just typed it out. But you can read this, and hopefully it describes everything well enough to you to understand it.